Welcome. This video will discuss input data related topics regarding the STREAMLINE automated machine learning tool. Overall, this video will cover STREAMLINE input data requirements, additional data considerations, and discuss the demonstration data that is initially set up to run within STREAMLINE. We'll start by covering input data requirements. First off, make sure any dataset files to be analyzed by STREAMLINE are in comma-separated or tab-delimited format. Specifically, STREAMLINE recognizes such datasets with the file extensions of txt, csv, or tsv. Next, make sure that data columns represent variables and rows represent instances. Additionally, any missing values in the dataset should be either left blank or indicated with the text NA. Make sure not to use any other placeholder values for missing values, such as 99, -99, or any text other than NA. Additionally, dataset files should each include a header row that provides column labels at the top of the dataset. Data columns in the dataset should only include the following, but of note, their order in the dataset doesn't matter. The first is outcome or class label. This is the dependent variable in the dataset, and its column is indicated to STREAMLINE by the run parameter class label. The second is instance label, which is the column with unique identifiers for each instance in the dataset. This column is optional, and its value can be indicated by the run parameter instance label. The third is match label, which is an instance group identifier used to keep instances of the same group together during k-fold cross-validation, specifically when using the group stratification option. The third is the match label, which is an instance group identifier used to keep instances of the same group together during k-fold cross-validation when the group stratification option is being used. This column is also optional, and its value can be indicated by the run parameter match label. Any other data columns should represent features in the dataset, which serve as independent variables. STREAMLINE will treat any other columns other than the outcome, instance, or match labels as features, unless the user indicates any other columns should be excluded using the run parameter ignore features path. Some additional input data requirements: the outcome column should only include two possible values, reflecting that it's a binary outcome, since STREAMLINE currently can only accommodate binary classification tasks. However, note that STREAMLINE will soon be expanded to multi-class and regression outcomes. If multiple target datasets are being analyzed by STREAMLINE at once, they must each have the same class label, and if present, the same instance label, and also if present, the same match label. All of these requirements over the last couple slides are also true of replication datasets. Now let's talk about some additional data considerations when using STREAMLINE. And firstly, let's talk about specifying feature types. Generally, it's recommended that users manually specify which features should be treated as categorical versus quantitative, using the categorical and quantitative feature run parameters. The categorical cutoff parameter can be used to help STREAMLINE automatically discriminate between categorical and quantitative features. This parameter defines the number of unique values observed for a given feature in a target dataset, after which that feature is automatically considered to be quantitative. This automated strategy can sometimes be used to correctly assign all feature types automatically, depending on the dataset. For example, if all features in the dataset have only 3 possible values, and the categorical cutoff is set to 4, all features would be treated as categorical. However, note that this automated assignment won't always work correctly on every dataset, and in general, we suggest that users manually define feature types in their dataset if this automated approach is not assigning features correctly. Furthermore, if multiple target datasets are being analyzed, then quantitative and categorical feature run parameters should include the names of all features to be treated as one or the other across all target datasets, even if those features don't appear in all target datasets. Now let's talk a little about text-valued features. STREAMLINE allows datasets to be loaded that have text-valued, in other words, non-numeric, entries. To this end, it's important to be aware of how the pipeline will treat different columns that have text rather than numeric entries. For the outcome label column, any text will be numerically encoded as 0 or 1 based on alphabetical order. The instance label column can commonly be non-numeric, and thus is never changed by STREAMLINE. However, users should make sure that all values in the instance label column are unique. The match label column is also commonly non-numeric, and is similarly not changed by Streamline. And with respect to features, any text values will be numerically encoded based on alphabetical order and will automatically be treated as categorical features. Of note, the occurrence of text-valued features will override any user specification of feature type within the quantitative and categorical feature run parameters. Next, regarding previously unseen categorical values that may occur in replication data. It's important to realize that this is a normal and expected possibility, and thus not of any major concern. However, new categorical values in replication data require some additional decisions to be made by Streamline when encoding categorical features with one-hot encoding. As an example, imagine there's a hypothetical feature in a dataset for hair color, and in the initial target dataset, values for this hypothetical categorical feature include black, brown, blonde, and gray. But some replication data also includes the previously unseen value of red within that same feature column. One-hot encoding would normally create a new column for each categorical value. However, the column in this case for red would not have existed in the processed target dataset or any of the trained models. Streamline addresses this problem during the processing of replication data. If the new value occurs in a categorical feature with more than 2 categories, one-hot encoding does not add a new column to the dataset, and the value for each one-hot encoded feature for that instance is set to 0. In other words, not black, not brown, not blonde, and not gray. And if there are exactly 2 categories, one-hot encoding again does not add a new column to the dataset, and the values for each one-hot encoded feature for that instance is instead set to a missing value, leaving value assignment to downstream imputation. Another data consideration has to do with binary class labels. Streamline assumes that instances with class 0 are negative, and those with class 1 are positive by default. This consideration is relevant to the definition of metrics such as true positive, true negative, false positive, and false negative. This impacts PRC plots, which focus on the classification of positives. Often, accurate prediction of the positive class is of greater interest than the negative class. And it's also common in datasets for there to be a larger number of negative instances than positive ones. So in general, it's best practice when using Streamline for the user to encode their own outcome label with 0 or 1 appropriately ahead of time to ensure that the right class is treated as the positive class. Lastly, we're going to talk about the demonstration data included within Streamline. The purpose of this demonstration data is to illustrate Streamline in action, as well as confirm that it's running as expected before applying your own data. All Streamline notebooks and command line interface examples have been set up to run on the demo data initially for convenience. The demonstration data can be found in the GitHub repository with the following paths, with the first corresponding to the target data and the second corresponding to the replication data. The primary demonstration data is a hepatocellular carcinoma survival dataset taken from the UCI repository. It represents a biomedical classification task, with outcomes of survived versus deceased after 1 year. It includes 165 instances and 49 features, as well as exemplifies many common biomedical data challenges, including mixed feature types of both categorical and numeric, data missingness of about 10%, and class imbalance with 63 deceased instances and 102 that survived after 1 year. The target demonstration data folder also includes a custom HCC dataset, which is based on the original UCI dataset, but was designed and simulated to test and confirm the functionality of Streamline's automated data processing steps. And along with this custom HCC target dataset, we've also simulated a custom HCC replication dataset, so that users can easily demo the entirety of the Streamline pipeline. Next, we'll go over exactly how the custom HCC target dataset was designed. It was simulated with modifications and additions, allowing it to be used to confirm that the data cleaning and feature engineering functionalities of Streamline are working correctly. The first modification to the original HCC dataset was removal of 2 covariate features, specifically gender and age at diagnosis. Next, we added 2 simulated instances that included a missing class label to test that aspect of basic data cleaning. Then we added 2 simulated instances with a high proportion of missing values to test instance missingness data cleaning. Then we added 3 simulated numerically encoded categorical features with 2, 3, or 4 unique values. This was to test the functionality of one-hot encoding as basic feature engineering. Similarly, we also added 3 simulated text-valued categorical features with 2, 3, or 4 unique values. Next, we added 3 simulated quantitative features with high missingness to test feature missingness data cleaning. And we added 3 pairs of highly correlated features, with 6 features added in total, with correlations of -1, 0.9, and 1. This was to test the high correlation data cleaning aspect of automated data processing. And lastly, we added 3 simulated features with either invariant feature values, all missing values, or a mix of invariant and missing values to test that aspect of data cleaning. Lastly, we'll discuss our simulation of a custom HCC replication dataset for the STREAMLINE demo. For this, we took the custom HCC dataset described on the last slide, and for 30% of its instances, we randomly generated realistic-looking new values for each feature and class outcome. This effectively added some noise to the dataset. We also added as-of-yet unseen categorical feature values. For this, we simulated further instances that test the ability of STREAMLINE's one-hot encoding to ignore new, as-of-yet unseen categorical feature values during STREAMLINE's replication phase. Specifically, to check if we got the desired behavior where the new value would be ignored. In other words, no new feature columns would be added to the replication data. On whole, we simulated instances with unseen values in the binary text-valued categorical feature, the 3-valued text-valued categorical feature, the binary numerically encoded categorical feature, the 3-value numerically encoded categorical feature, and each of the invariant feature columns. Thanks for listening to this discussion of input data using STREAMLINE AutoML. Please feel free to reach out if you're interested in collaborating or if you have any questions.